So when we're going to multiply and add rational expressions or dealing with square roots, we have a couple rules we're going to focus on. So first, whenever I'm multiplying, if I have two numbers within the radical, I can multiply them together inside one radical. So if they're both square roots, they can go inside and be multiplied. Also, if I have kind of a simplified radical form, a root b times c root d, the a and c can be multiplied together, and the b and d can be multiplied together. These are both rational numbers. These are both irrational. So you can multiply those common values together to get a result. So it's going to also add on to our simplifying radicals, which we just looked at. So if we start with something like the square root of 2 times the square root of 8, multiply together, that gives me the square root of 16, which we should know is 4. The square root of 3 times the square root of 6 gives me the square root of 18. Now 18 is 9 and 2, which from the 9 I get the set of 3's, and that's going to come out, leaving the 2 inside, and we call that 3 root 2. For the next one, I'm going to multiply the outside two values. I get 6, and on the inside it's 5 times 10. But before I multiply those together, I've kind of already started factoring it, because 5 times 10 is 5, or 10 is 5 times 2, which actually gets me a set of 5's there. That comes out, leaving the 2 inside, and our answer is 30 root 2. Now when we look at 4 root 6 times 2 root 12, I multiply the 2 on the outside, I get 8. Then I have 6 times 12. Well, 12 is 6 times 2. Pair of 6's come out, that's 8 times 6 root 2, or 48 root 2. Now we're going to bring in some variables. So we get 2 times 12 times x to the 4th, because I have 1x and 3 x's, that gives me x to the 4th. 2 times 12 looks like it's going to be 2 times 2 times 6 x to the 4th, meaning a set of 2's are going to come out. And if I have x to the 4th, 2 sets of 2 come out, leaving me with just a 6 on the inside. So we read that as 2x squared root 6. For our next one, I have square root of 12x to the 3rd and 3x to the 6th. I'm just going to multiply these two this time, because then I get 36x to the 9th. I could have left them separate and factored 12 pulling out of 3, but I actually could have kept factoring it. I like this because 36 is a perfect square that comes out. X to the 9th is going to be 4 sets of 2 to come out, leaving 1 behind, so we have 6x to the 4th square root x. For our last one with multiplying, I have 8x to the 5th, y to the 3rd, and 4y to the 8th. So I have 8 times 4, x to the 5th, y to the 11th. 8 and 4, it gives 2, 4 and 4. So these 4's come out. 2 stays inside. The x to the 5th is going to take out 2 sets of 2, leaving 1 behind. Y to the 11th is going to take out 5 sets of 2, or 5 times 2 is 10, leaving 1 behind. So we read that as 4x squared, y to the 5th, square root of 2xy. Now we shift to addition and subtraction. When we have addition and subtraction, we almost want to think of the radicals for when we do the actual operation as a variable. So if we said square root of 7 plus 4 root 7, if it was x plus 4x, you should just write that as 5x. And this is going to follow the same idea. It's saying how many root 7's do we have? We have 1 root 7 plus 4 root 7's. So we have 5 root 7. We could go again on the next one. 8 root 3 minus 3 root 3 is going to be 5 root 3. Notice I did not change the radical here. I'm not multiplying them together. I'm just adding the terms. We go to the one on the far right here. 8 root 13 and 7 root 13 is 15 root 13. Now all of those are simplified down. I can't pull out any more perfect squares and simplify down, and we're good with that. But in this next row, we have to go a little bit further, because if I look at 4 root 3 and square root of 12, they're not the same term. I can't combine them. So what can I do to the square root of 12? Square root of 12 is 4 times 3, and 4 is giving me the pair of 2's. So this becomes 4 root 3 plus 2 root 3. Which now they match, and I can say this is 6 root 3. The next problem is going to follow the same idea. I have to simplify them down and get them to match up. Well, 18 is 9 and 2, which gives me 2 3s. So that's going to come out. I have an x already. X to the third is going to give me another 1. What's left behind is the 2 and the odd x. So this becomes 3x squared square root of 2x. Now in order to add this to this term, it's got to be the same parts here. So 32 is 16 times 2, which is 4 and 4. So that's going to be 6 times 4. We're going to leave a 2 behind. X to the 5th takes out 2 sets, leaving 1 behind. So down here we get 24x squared square root of 2x, which matches. So these both work. We combine them, we have 3 plus 24 is 27x squared square root of 2x. Our last one, square root of 32 minus square root of 8. 32 is 16 times 2. The 2 4s there come out, give me 4 root 2. 8, as we've already seen, is 4 and 2, which takes out a pair of 2's, so that is 2 root 2. So 4 root 2 minus 2 root 2 is 2 root 2.